Hello Math 1324 students. Let's begin Lesson 2, Linear Equations and Inequalities 2. It's a continuation from Lesson 1, where we covered Section 1 of this notebook. Lesson 2 will cover the rest. In Section 1, we studied linear equations, and here's the basic strategy: denominators, parentheses, and like terms in that order. But here, all the questions here had only one character. Only one variables to work on. Here, we have more than one characters at the same time. For example, 4x plus 3y is equal to 12, and what is y in terms of x? Here's another. 5x minus 4p is 1200. What is x in terms of p? And what is p in terms of x? Even more advanced examples include more than two characters. Here's an example. T is, we need bigger font. Even bigger. Okay, that's better. T is x minus m over s over square root of n. What is x in terms of the other characters? By the way, this expression here is very, very important in statistics. How about the next example? This one is important in physics and engineering. E equals to mgh plus 1/2 mv squared. What is h in terms of other characters? And what is m in terms of other variables? Here's one more. W is 3z plus 5 over negative 2z plus 7. And so for z, with respect to w, and this kind of expression is called Möbius map, and it's important in really various different subparts of pure mathematics, pure and applied mathematics in advanced level. They're all important examples, as a matter of fact, and basically the same technique is applied. Denominators, parentheses, and like terms. Remember this, and you're going to be ready. Ready? Okay, first example. I got this one from the textbook, so it's really simple. And then we are solving for y. Okay, we are solving for y, which I'm highlighting in green. So keep y in one side and push everything else to the other side. Or let me write it in this fashion. Negative 4x plus 12. Either way is okay because addition is commutative, but it's a little bit more convenient to do it this way, especially if we associate this with geometry. Anyway, let's go one final step. Divide by 3, then y equals to dividing by 3, and then 12 divided by 3, and that's 4, isn't it? And then that's what we get. Now, everybody went through intermediate algebra and basic algebra and pre-algebra as well. So you must know what this is. Geometrically speaking, what is it? It's a line. It's a line with slope negative 1/3 with y-intercept 4. And this expression is of the more general form, but solving for y, we get the slope-intercept equation. What if we want to solve for x? Well, we can do that. The problem did not ask you to find out with respect to x, but you can do that if you want to. So for x, so push everything else to the other side. For x is equals to 12 minus 3y, or equivalently speaking, negative 3y plus 12. And then divide by 4. X is negative 3 over 4, y plus 12 over 4, and that's 3, isn't it? You can solve it like this too, with respect to x, or you can solve it like this with respect to y. You have to get the problem. Problem says solve for y, so this is the answer. But if the problem asks you to solve for y, part A, solve for x, part B, then you have to do both. This problem asks you to find out only for y, so I'll just do the first one. How about the next example? It's going to be equally a simple example. And let's solve for x first. How do you solve it? X is a quantity I want, so keep it to the left-hand side. Push everything else to the other side. Change the side, change the side. Remember? By the way, let's rewrite it, and for p plus 1200 like this, as we did before. And divide by 5, and you're going to get the x. Divide it by 5. That's it. If, by the way, if you want decimal expression, and then this is going to be what? 1200 divided by 5, 240. Okay, we can rewrite like this. Oh, by the way, this is 240. Okay, then 240. You can rewrite it in terms of fraction or in terms of decimal. Either way, it's okay. Now that was for x. How about for p? No problem. This time I want p, so I'm going to push the other term, 5x, to the other side and keep minus 4p here, and then I can do it like this. Make sense? And then I can divide by 84. Oops. Divided by 84 x plus divided by 84. Negative, negative, positive, so this becomes 5/4. And this becomes, let's see, negative 300. Or equivalently, you can write it like this, 1.25x minus 300, using decimal if you prefer. Let's see. What did I do in the answer here? Yeah, they're the same thing. Same. Well, too elementary. How about something more advanced? Well, we don't have enough time, so we'll just do one example problem. Let's copy and paste this thing. And then we are looking for x, right? And then fraction with all these, I'd better use a little bit bigger font. Okay, alright. And remember, the quantity I'm looking for is x, which I'm highlighting in red. Okay. Step 1, denominator. Do we have a denominator to remove? Yes, I do. I have this quantity. So let's multiply this quantity to both left-hand side and right-hand side to remove the denominator. Make sense? So multiplying this quantity, s over square root of n, to the left-hand side, we get this. And then multiplying this thing to the right-hand side, we're going to get cancellation. And I'm going to get just x minus m. Make sense? And then I can have multiplication by s over square root of n. And that thing down here cross each other out. And then I'm going to get only x minus m. So do you see this crossing? This one and that one? That always happens whenever you multiply out the denominator. Essentially, it flipped over to the other side as a multiplication. Okay, we're almost there. We are looking for x. Right-hand side is just x minus m. So if you just flip this m to the other side, add it away, then I'm going to get my x value. X is m plus t s square root of n. Okay, that's the solution. This expression here is going to be important in statistics. That too is important in statistics. I can solve for other variables such as s or m or even n, but I'm going to leave those as an exercises for you. I don't want to go too deeply into this. Now, do we have enough time for other problems? No, let's stop here and let's consider other problems in a separate video. Let's stop here. See you soon.